Alright, power property of logarithms. Right here. If an input has an exponent in it, you can just put it to where it's multiplying the log and it equals the same thing. So just to get that out of the way, that's what the power property of logarithms is. And the example that I'm about to go through is in the 6.22 notes. We're just going to jump in and I'm just going to show you how you would do this. So we're just going to get right on into it. We're going to start with question 1b for this example, and it says rewrite x equals log base 2 input 30, then convert it into exponential form. So we have x equals log base 2 input 30, and to rewrite that in exponential form, if you watched my last video, you should know how to do this. This should be 2 to the x equals 30. That is exponential form. And then we can basically forget about this. This doesn't matter anymore. So now, this is where the power property of logarithms will come into play. So what we do first is we take these two equations and just put logs in them and still make them equal to each other. What I mean by that is we then go to log input 2 to the x equals log input 30. That's where we go from here. And now, with the power property of logarithms, you'll notice that this 2 to the x looks pretty suspicious to this a to the x. So you might be thinking what I'm thinking, right? You just move the x over here. So then we get x times log input 2 is equal to log input of 30. And we all know how these equations go. If we're trying to find x, we have to isolate it. So we divide by log of 2. So if we keep going, we now have x equals log of 2 over log of 30. This is Zeus in post, and I meant to put log of 30 over log of 2, because if we're dividing by 2, you put that under log of 30. So do not listen to what I'm saying right here. It should be log of 30 over log of 2, but I'm too lazy to go and fix it, and yeah, this is what I've decided to do instead. So log of 30 over 2, not log of 2 over 30. You still get the answer that I'm going to show, but it's log of 30 over 2, not log of 2 over 30. And the great thing about this is that notice how these logs don't have a base, which means they are in base 10. And since all our calculators are in base 10, you can just immediately put it in the calculator, get your answer. And in this case, the answer was approximately 4.90. So that's how you would do the power property of logarithms. That's how you do a basic problem. And now let's go for another example. This is question 2a on the same 6.2.2 note assignment. It says, try the same method on your own to evaluate log base 5 of 200. And of course it equals x. So then we have 5 to the x equals 200. And then, like we did before, now we just do log 5, input 5 to the x equals log input 200. And now we just do the power property of logarithms again. So you move the x to its multiplying the log. So you have x times log base 5 equals log input 200. Excuse me. We have to isolate the x. So we divide by log base 5. So then we have x equals log input 200 over log input 5. And with this, you get an answer of approximately 3.2920. So these are basically how you solve these types of problems. And also, before I end this video, I just wanted to touch on something that I think may be confusing to a few people. This example is on the 6.2.1 notes that we also did in class. This is question 6C, actually 6D, because apparently there's a typo on the paper. I just noticed that. That's kind of funny. But anyway, the problem is 2 times x to the 8 equals 128. So the first thing we would do is get rid of this 2. That's the first thing that we want to do. So we just divide by 2 on both sides. So this 2 gets canceled out, and we're left with x to the 8 equals 64. Now, in order to solve this problem, let's just say, for example, let's just say that we had x squared equals 25. Just to get an example. So the opposite of a square is a square root. So you do x squared to the square root equals 25 square root. And then you get x equals 5, because 25 square root, the square root of 25 is 5. So a power is just multiplying something by itself that many times. So 2 squared equals 4, because 2 times 2 equals 4. There's 2 2's. There's 2 2's. 2 to the third power equals 8. There's 3 2's. 2 times 2 times 2 equals 8. So if we have a square root, right? Basically, if we have a square root, it's basically saying, right? So if I have the square root of 25, it's basically asking what number multiplied by itself, because you know, it has to be 2, what number multiplied by itself gives you 25? And the answer is 5. The answer is 5. So, in order to do this, we have to take it to the 8th root. Which, if a square root, and you'd write it like this, if a square root is what number multiplied by itself will get you that answer, an 8th root is what number multiplied by itself 7 times, technically 7 times, will get you 64. So now that we have this, obviously the 8th power and the 8th root cancel out, leaving us with x equals the 8th root of 64. And if we were to do the 8th root of 64 in our calculator, that equals approximately 1.681. Approximately. So basically, what that means is that if you were to take 1.681 and multiply it by itself, actually, let me write an actual multiplication sign. So what that means is if you were to take 1.681 and multiply it by itself 7 times, so you have 8 of these in total,
written down, if you did it 7 times, it would equal approximately 64.
So that's basically what that means. If any of you were having trouble understanding that concept, I'd recommend getting a good calculator for this, because I have my own calculator, right? And the calculators that they provide in Chandler's class are, I don't know how to work them, okay? And this is just personal preference for me, right? But the calculator that I have is a Casio FX-300 ES Plus. I will post a picture at the end of the video probably, or at the beginning. I don't know how I'm going to edit this video. But there's a really easy setup to that calculator, so I'd recommend that calculator. But if you don't have a calculator or can't buy one for some reason, just, I guess, try and learn how to use the calculators they provide, because, yeah, it's kind of funky, but, yeah. I just wanted to get this concept across. So, yeah, that's it for this video, and, that's it. Peace.